Okay, everybody, very good afternoon to one and all. Good afternoon, everyone. Welcome to Study IQ. I hope that all of you are getting the voice, video, everything properly. Hello, Kaluv and Ashirvad, Bhuvnesh, and Sundar, Rajan, Mahak, and Jai Shakti, Nivedita, Chanchal, okay, and Elombini, Shantanu, everyone. A very good afternoon to all of you. Guys, kindly confirm that if you are getting the voice and video, everything is properly. Graduated from history to science, not exactly. Not exactly. Actually, the thing is that ki, just a second. Just a second, everyone. Just a minute. Let me call somebody. Okay. So modern history. Okay, that's great. मॉडर्न हिस्ट्री के साथ साथ इनफैक्ट अगर मैं बात करूं तो मॉडर्न हिस्ट्री के अलावा आई हैव आल्सो बैकग्राउंड इन द मैकेनिकल इंजीनियरिंग राइट सो इट इज डेफिनेटली द साइंस आल्सो बट साइंस जो हम लोग डिस्कस करेंगे यहाँ पर दैट विल बी वेरी बेसिक राइट इट विल बी वेरी बेसिक guys kindly confirm if it is completely English batch. Yes, okay, that's great. Okay, fine. So because earlier it was a bilingual batch, so that's why I was a little bit confused whether we should be using the both the languages or simply a complete English. Anyways, so guys, let me call somebody who will be coming up to just set it up, right? Otherwise, okay, here it is. Let me just do it myself. PC. Okay, everyone. Wait a minute. Just wait a minute. Let me set it up. So guys, as far as the syllabus of information, right? In fact, I'm sorry, that is a bureau, the Intelligence Bureau examination is concerned, we must understand one thing that the particular, right? ये setup करना था, हो गया ये. Sorry. The examination of the Information Bureau is concerned, in fact, Intelligence Bureau is concerned, I'm sorry. So we have a very small scale of the general study subjects, just 20 questions from all the GS subjects, which include the science as well. And therefore, we are expecting a very modest of say like 2 to 3 questions or 4 questions at max to max on the examination paper from this particular subject. Now, if we talk about, okay. If we talk about the paper and the subject both, we have a total of how many? 20 questions, okay? And these 20 questions of general studies, where we will be getting approximately, say, 3 to 4 questions of science, okay? And what will be our approach in this particular subject? Because let me tell you very honestly that in 2023 or 24 even, they did not ask a single question from science. So how does it make you feel that you should be paying some focus, some attention, as well as some time on this particular subject? It is because in the earlier examinations as well, they have asked quite a few questions. So here, let me tell you that we are going to cover, right, total of 6 lectures, okay, 6 lectures in total, clear? Out of those 6 lectures, we will be allocating 2 lectures each, okay, 2 lectures each to physics and chemistry. In fact, chemistry would be that just 1 lecture, okay, just 1 lecture, and 3 lectures for bio. Okay, 3 lectures for bio. So overall, how many? Overall, we are having 6 lectures, and let me tell you that the approach that will be very basic. We will not be indulging into the deep derivation based something like that. We will just be doing some sort of very simplistic, very one day oriented kind of subject in this particular science. Okay. At the same time, the practice questions that would be provided to all of you, apart from the classroom discussions, apart from the classroom content, you do not need anything extra, anything except some practice questions which would be provided to all of you after these 6 lectures are over. Your student profile that would be having, along with the notes, I think probably 50 questions from physics, chemistry, as well as 100 questions from bio. Okay, all these things that will be provided to you. Okay, you just joined this. No, you did not miss anything. Audio mic is getting distracted. Mic disturbance is there. Voice is cracking a lot. And why so, my dear? Why so? There should not be any kind of cracks in the voice. Audio is not clear while moving. Guys, is it the problem for all of you or is it only for few people? Kindly confirm. Whether it is current oriented science or static. Joel, it is general science. It is a static, highly static in the nature. Okay. Okay, so all of you are saying that mic issue is there. Okay, once again, let me call. Just a minute. I have already called, some technical assistance, so that will be, I think. Achha, when I move, then it is more important. Brushing with the cloths which moves are causing. Okay, Milan. Actually, all the mics keep brushing with the cloth. There is nothing new in that, but I don't know why exactly it is causing disturbance here. Just a minute. I don't think so. Voice issues. I think any of voice issues. It is saying that the audio is cracking. Camera off. इधर से ऊपर को I think आवाज आ रही, right? Everybody is getting the voice properly. There is no disturbance at all. If kindly confirm it, everyone. I think there is no noise at all at the moment. Yes, it is proper, audible, good, fine. Okay, thank you, ma'am. So guys, we are going to start the physics first of all, okay? As far as the physics is concerned, let me tell you that we will be doing only the very important and very few topics. And what are those topics which we are going to cover, except, the quantum mechanics and all that? We are not going to touch those topics at all. We are just going to do some very basic physics, including the, the classical mechanics or the Newtonian mechanics. Apart from that, we are going to cover the, the basic heat and thermodynamics, the daily based questions like why do we have the cloths drying up quickly in the summer, or such kind of things. Then we will be doing a topic of electricity, semiconductors, diodes and all that. So basically all those topics which are touched or covered by the one-day examination, where they ask some very basic questions of the science, that is what we are going to cover in our physics, just in 2 lectures, today and tomorrow. Okay. Amritanshu Kumar ji, voice is absolutely intact. It is the problem at your end, my dear. So kindly check it once. Okay. Now let us start this particular session here. And first of all, we will be talking about the physics, and particularly, guys, we all are aware that physics is basically of 2 types. We all understand that the classical mechanics and the quantum mechanics. Here we are not going to talk about the quantum mechanics. We are just going to talk about the classical mechanics. What are the sources and what is the method that we are supposed to adopt in order to understand the science as a subject? So guys, if we talk about the sources of science, so here let me tell you, only classes plus practice questions, okay, plus practice questions, obviously along with the PYQs, okay, along with the PYQs. And what is your approach or the method? So you just have to make sure that revise more and more by solving questions. There is absolutely no other way. Absolutely no other way. IB ACIO Telegram channel. Okay, so IB ACIO Telegram channel, if it is already subscribed by you, then it is okay. Otherwise, there is no personal channel that I have created for the IB ACIO, etc. You guys can create a channel, or maybe if you have already attended any kind of channel related to the IB ACIO of the Study IQs program, then you can join that as well, right? All the questions and the content on the daily basis, that would be uploaded on your student portal of Study IQs, right? There is no other way, and there is no other place where we will be uploading the files. Okay. In case if you have any kind of personal queries or the questions, etc., so you can simply connect with me. That is on my email ID, that is abhishek.singh2@studyiq.com. Okay, this is what you can do. There is not much fuss to worry about. It is just very simple, quick, short, and very easy thing that we are going to cover. So let's get started now. So guys, we are going to talk about the classical mechanics. Now, what is the meaning of the classical mechanics that we must understand here? Any object, if it is studied on the basis of its physical qualities, then we call it as the study of that classical mechanical object, and it must be of the size greater than or larger than 1 nanometer. Okay, suppose if we are studying the physical properties of this particular substance, this particular object, then we are talking about the classical mechanics. It could be of any shape, it could be of any size, it could be of any material, it could be of any size greater than 1 nanometer. So what all physical properties are we going to study? It could be related to the pressure, could be related to the force, it could be related to the friction, related to the expansion, heat, anything. So my dear, what is the classical mechanics that basically we talk about? We talk about all the physical properties that any kind of object may possess, and the study of those properties, those activities related to the physical qualities, given that the object size must be greater than 1 nanometer. If it is smaller than or lesser than 1 nanometer size, then it becomes quantum mechanics. Basically, we study that quantum mechanics at the atomic level, and we are not going to talk about that. Okay. So the very important topic of the classical mechanics basically starts with or begins with the understanding of the measurement units in the physics. Guys, when we talk about the measurement units in the physics, let us understand that the measurement units, okay, measurement units, they are used to measure the physical quantities, such as mass, area, volume, okay, density, etc. Got it? Very, very simple. Do you have to write anything? I don't think so. It's not very much necessary for you. You will be getting each and everything which is being noted here on the PPTs on your student portal itself. So no need to worry about it. Just listen to this very carefully. In case if you get to happen any kind of doubt, if you get to have any kind of doubt, just ask it about. Okay, just ask about it. So guys, we have the physical quantities and the methods or the tools which we use to measure these quantities, that is known as the measurement units. And here we have the example of the units that include the meter or kilogram, etc. Okay, all these things. When we talk about the measurement units, okay, guys, these are divided into two types of units, which include, number one, the fundamental units, basically used to measure the fundamental quantities, okay, fundamental quantities. And then there are the derived units. And derived units are basically used to measure derived or calculated quantities. The question arises that what is exactly, okay, the question arises that what is exactly the meaning of the fundamental quantities? Okay, Rishabh ji is saying that please take concepts in little deep. My dear, neither we have the time nor we have the requirement to take the concepts little deep. Okay, here we do not need to connect the concepts because the questions are not like that, unfortunately. I'm sorry for this, because I myself believe in taking on these kind of subjects in the very conceptual manner, but unfortunately the examination doesn't think so. So we have to be very much objective. In fact, the word which I just hate to use before my students, that is just cram it, just completely memorize it. This word also I will be using repeatedly, frequently for many kind of topics in this subject. So unfortunately this exam is like that only, so you have to be as per the examination, not as per your preferences. I'm sorry. Will you solve the PYQs in the class? PYQs is something that you have to solve. I will be giving you some practice questions in the class, definitely. There is no doubt. Okay. So guys, here we got the two things, fundamental quantities and fundamental units. Okay. Derived quantities and derived units. Now the question arises that what are the examples? If the examiner asks, suppose there is a question that which of the following is a fundamental unit, your choices are given, right? Suppose mass, okay, mass or length or volume or A and B. Okay, so mass, length, volume, A and B, fundamental unit or fundamental quantity. So mass and length, these are both fundamental quantities. Volume is not a fundamental quantity. But how can you exactly define that? How can you exactly say that? So my dear, when we talk about the fundamental units, these are expressed independently, okay, independently of any other quantities. Okay, my dear, which means that you can actually express the fundamental quantities independent of any other quantity. For example, to describe the length, you do not need, or to describe basically the meter, you do not need anything else. You just need to have that length purpose, right? But when you start doing some sort of calculations by using the length parameter, then you get the area, then you get the volume, isn't it? Similarly, if we talk about the mass, you don't need anything else to tell what is exactly the mass. But when we talk about density, then you require mass as well as volume, isn't it? So basically, when we talk about anything that is basically used to be expressed independently, then it is absolutely fundamental. Bhuvnesh says that area is fundamental. No, area is not fundamental. Why? Because here the length is being multiplied by the length. The length is being multiplied by the length. Okay. So there is some operation that is going on, isn't? If it was just about length, it was just about length, then it was a fundamental quantity. Okay, but area is something where we need to measure the length, and then we do some sort of operation on it, then it is. And mass is fundamental. Yes, mass is absolutely fundamental. Guys, tell me exactly that is temperature a fundamental quantity? Is temperature a fundamental quantity? Please everyone answer quickly in the comments. Is the temperature a fundamental quantity? Yes. Very good. बहुत अच्छे. Very good. Shantanu says derived. No, it is not derived. Temperature is absolutely fundamental. Temperature is absolutely fundamental. We do not need anything else to tell exactly what is the temperature. But if we talk about anything else, for example, say work done or heat, these are some derived quantities. These are the derived quantities. Okay. Rain measurement, yes, derived quantities, exactly. So guys, there are just very few. What about climate? No, climate is nothing related to that. Climate is nothing related to that, my dear. Climate, how can you measure the climate, my dear? Ashirwad Bhartiya ji, how can you measure the climate? Are you listening to yourself? Aniket Das is saying weight. Weight is actually a derived quantity. Weight is not a fundamental quantity. Celsius Sadhvik ji, Celsius is just one of the measurement units. It's not about the fundamental nature or something. Celsius is just the measurement unit of the temperature. Okay. Weight is proportional to gravity, hence derived. Very nice. Very nice. Okay. Amritansh Kumar saying that, are you saying temperature is fundamental and Celsius is derived unit? Not at all, man. Come on. Don't talk like that. Huh? Celsius is just a scale to measure that temperature. Temperature is the quantity. Celsius is nothing. Celsius is just a scale, right? Celsius is just a scale to measure that quantity. Okay. Horsepower, ampere, derived. Ampere is not derived. Ampere is the fundamental unit. Okay. Pressure is derived. Pressure is derived because pressure is force upon area. Force upon area. Gravity, it is not fundamental. Gravity is any kind of acceleration, right? We don't need any other to calculate. We call it as the fundamental. Yes, exactly, Quresh. Exactly. Kelvin is also fundamental unit. Anisha ji, Kelvin is. Now, guys, let me tell you. Here we are saying that, right? Here we are saying that the fundamental units or the derived units, if we talk about, see, units are something, right, which are actually used to measure the quantities, right, which are used to measure the quantities. Okay. So, my dear, when we talk about, right, when we talk about the fundamental quantities and their units, we have the length, we have the mass, we have the time, we have temperature, we have current, we have luminous intensity, and we have the amount of matter. Okay. Length is basically having the fundamental unit called as the meter. Okay. Mass, kg, right? Time is second. Temperature is Kelvin. Current is ampere. That is candela. Okay. Candela. Amount is mole. Okay. So this is something that we are actually having. Okay. That is we are having. So overall, these are the fundamental quantities. Okay. And these are their basic units. These are their basic or basically SI units, right? Now, if we talk about the derived quantities means anything which is the product or which is the derivation of this is something which is used to get the derived quantities. For example, area, length into length, okay, means area is derived. This is fundamental and this is fundamental. Okay. So I think you all understood this point, that area is derived because we used two different measurement units and then we get the area. Okay. Got it, everyone? Right. So this is basically your length and this is your breadth. Breadth is also a kind of length only, so we can write it down. Okay. Now, guys, if we talk about some examples here. So these are certain examples of the SI units or the base quantities. You can see this one, right? So you just need to remember these basic definitions: length or mass, time, current, temperature, amount of substance, and luminous intensity. Okay, luminous intensity. These are called as the 7, right? How many? 1, 2, 3, 4, 5, 6, and 7. So total there are 7 fundamental quantities. Okay, total 7 fundamental quantities. So in the physics, we have these 7 fundamental quantities with the help of which we get all other quantities, all other units to measure and everything else. Okay, there are several kind of measurement systems. There are several derived units or derived quantities with the help of these fundamental quantities. Okay, everyone, that is something very, very easy to understand. Now, what kind of questions would you expect from this topic? So there would be a kind of question, for example, question. Okay, consider the following. Okay, consider the following and match the correct ones. Match the correct ones. Okay, fundamental quantity. Okay, fundamental quantity and base unit. Okay, so here it is amount of matter, temperature, length, and mass. Okay, amount of matter, kilogram, temperature, Kelvin, length, meter, and mass, mole. Okay, so the question is that how many of them are matched correctly? Okay, everyone. So 1 and 2, 2 and 3, okay, 3 and 4, 1 and 4. Yes, everybody, answer. How many of them are matched correctly? 1 and 2, 2 and 3, 3 and 4, 1 and 4. So this will be the level of questions. So do not expect some very high-fi questions that you won't be able to answer. You would be able to answer it very, very easily. Very, very easily. Okay. So guys, did you get the point here? Amount of matter is mole. So this is not correct. Mass is kg. So this is not correct. Temperature is Kelvin. Length is meter. These are both correct. And the answer would be what? The 2 and 3. This will be the answer. Okay, this will be the answer. Did you get the point? I hope everyone understood the basics of this topic. Okay, now guys, let us move to the scalar and vector quantities. So when in the physics we study about the quantities, my dear, we talk about two kinds of quantities. Two kinds of quantities. One quantity which has only the magnitude. What is the magnitude, by the way? Magnitude is basically a certain value, certain positive value. Okay, which actually does not have any kind of specific orientation or a specific direction. It just has a value. For example, let me tell you, suppose there is a little bit of water in this bottle. So if I ask you that how much water does this bottle have? So you can say that, sir, 100 ml. So milliliter milliliter or ml, that is the unit which is used to measure the volume or measure the quantity of the liquid. Okay, so here you can see that volume is actually being measured in certain value. What is the weight of this, what is the mass of this particular object? It's you should say like 100 grams. Okay, 100 grams. So guys, 100 grams mass, the speed of the train, say 100 kilometers per hour. Got it? Volume of this entire room, say 300 cubic meter or 300 cubic feet, anything. So my dear, there are certain physical quantities which have only a certain value but no specific direction. Then we call it as the scalar quantities. In case if a particular physical quantity has got, it has gotten a direction also along with some value, then we call it as the vector. Okay, everyone? So now tell me one thing. Suppose a bike is moving very fast and it is taking a right turn. Okay, so would you say that it is the speed of that bike or the velocity of that bike? Or in general, if you see any bike or any car moving, you call it the speed of that bike or velocity of that bike? It is the velocity. It is the velocity. Why? Because it is moving in a certain direction. In certain direction. Okay, it is moving in certain direction. So when you have that movement in direction, then it is called as velocity. Otherwise, in general, it is called as speed. So these are two things, speed and velocity are two things which create a lot of confusion among the students and examiners' favorite. They are examiners' favorite. The examiner, that keeps asking. They keep asking almost every year this kind of question. But speed, always a direction. Okay. Bhuvnesh Kumar ji, speed always had a direction. Acha. In that case, my dear, would you tell me that exactly which direction? Is that having a specific direction? Speed could be of any direction. Na? Speed of light. What is the direction of light? It could be in any kind of direction, all the directions. But when we talk about the vector quantity, it has a specific direction. There is a difference. Okay, there is a difference. Okay, there is a difference. All right, Bhuvnesh. So if the car is moving in a specific direction and then coming back, the velocity will become 0. Good. Otherwise, but speed will be there. So velocity has that additional element of direction. Obviously, speed has that value. Okay. But apart from speed and velocity, rest everything else you can see, it has a very clear and very distinctive calculations of the direction as well as the magnitude. For example, if you say there is a certain mass to this particular block, say it is 2 kg. Okay, say it is 2 kg. Suppose this block is of 2 kg. Okay, everybody. But since it is kept in a certain direction, so therefore the impact which it is putting towards the ground and towards the surface of this block, that will be different. Okay, that will be different. So it means that this mass is working in a certain direction along with the gravity, right now. So therefore this will not be mass, but it will be the weight which is acting upon this particular surface. So this is why weight is a vector quantity, but mass is actually a scalar quantity. So when we say that this particular toy or this particular remote has a mass of 100 grams, it is a scalar quantity. But when we say that it is dropping on the earth due to gravity, then the weight is into the consideration, because weight always acts towards the gravity. Are you getting my point? the weight always acts towards the gravity. The mass is independent of everything. Your mass is 50 kg on the earth, 50, sorry, not 50 kg, 60 kg, right? 50 kg is too light. Okay. So your mass is 60 kg on the earth. It will be 60 kg on the moon. It will be 60 kg in the space as well. Your mass will be constant. But your weight is actually, say, like 600 newtons on the earth. It will be 1 by 6th, say almost 100 newtons on the moon, and on the sun it will be much more than what it is on the earth. So your weight depends upon the gravity of the surface, and therefore the weight always acts towards the gravity. So what is exactly the weight? What is exactly the weight? So weight is equal to mass into, right, mass into gravity, mg. Okay, that is weight. Velocity is basically what? Velocity is exactly of the same value of the speed in most of the cases, but with a direction. So velocity is like that. Okay, got it, everybody? So that is about the vector quantities and the scalar quantities. Scalar quantities, vector quantities. Now, Bhuvnesh says that distinction is coming to understand the speed. Yes, exactly, Bhuvnesh. Because in calculations also, Bhuvnesh, we take the speed and velocity. When an object is in the moving condition, we take both of them to be the same only. Got it? Now, so I hope that all of you got the scalar and vector quantities. Now there is a question based upon it. There is a question based upon it. Solve this question. Consider the following statements. Consider the following statements. Okay. Scalar quantities. What is this, man? Scalar quantities have magnitude only. Okay, magnitude only. Vector quantities have magnitude and direction both. And 3, example of vector quantities include mass, velocity, acceleration, etc. What is this, man? Select the correct option. Okay, guys, can you see that the words are disappearing? They are disappearing like some sort of magic. Okay, so correct options: and A, 1 only, B, 1 and 2, C, 2 and 3, and D, all of 3. Yes. So what do you say that? Scalar quantities have magnitude only, vector quantities have magnitude and direction both, and vector quantities have the example of mass, velocity, acceleration, etc. Okay. Very good, Ashirwad. Very good, very good. Mass is a scalar. Yes, exactly. 1 and 2, 1 and 2, 1 and 2. Option B is correct. Absolutely correct. So my dear, option B is absolutely correct. 1 and 2 are absolutely correct. So I think that you can solve these two simple topics very easily. Such kind of questions I think you should be expecting in the examination as well. Nothing big, nothing surprising, not very much difficult questions are going to come. Okay. Now let us move to the next topic to understand the speed, velocity, acceleration, etc., etc. So guys, now when we talk about speed and velocity, these are probably the two most confusing quantities for any candidate. But let me tell you that the speed is something, yes, exactly, Podil. Exactly, Podil. Something that basically, used for an object to indicate the rate of change of its position. Okay, rate of change of its position, of course. But guys, velocity is actually the rate of change of its position and in a certain direction. So I told you that when you add only the element of direction in the speed, it becomes velocity. Otherwise, it remains speed only. So when you cannot express the direction, it is speed only. It is speed only. Okay. So guys, what is the exactly acceleration here? So acceleration is the rate of change of velocity. Okay. Means, my dear, suppose velocity and speed, both of them are measured in the meter per second. Okay. So let me tell you that velocity and speed are both measured in meter per second. Okay. And acceleration is basically changing velocity per second. Yani that is the rate of change of velocity. Okay. If increases, then acceleration. Okay. And if decreases, okay, if decreases, then deceleration. Okay, everybody. It means, for example, suppose if a train is moving, like, anything, train is moving. And if we try to count or calculate the speed of the train, it simply comes to be, say, 100 kilometers per hour. Okay, 100 kilometers per hour. Got it? But for any instant when the train is moving, the speed and the velocity are both the same values in the measurement. However, when we consider the direction in which the train is moving, then it is actually the velocity which we are measuring in the meter per second. So distinctively, we cannot separate both of these unless if we talk about the specific reference of direction. Okay, that is why we must not be mugging up too much about the direction and the value of the speed. Got it? So here, what is acceleration? I hope that velocity and speed, that is both clear to all of you. But what is acceleration? So guys, acceleration is something at which, that is the rate at which the velocity changes per unit time. Okay. Rishabh says, but generally we use the speed of car because, generally to calculate the direction, it is not in the possibilities of that odometer that we are using to, or speedometer that we are using to measure the speed. So speedometer actually measures simply the speed of the wheels at which it is moving, nothing else. Okay, that's the case. So practically the velocity comes into the picture when there is some sort of collision, right? Something else. Got it? So guys, here we are talking about the acceleration and deceleration. Suppose you are riding a bike and you are increasing the speed of the bike. You are increasing the speed of the bike. But even when we talk about the speed, we use that term acceleration. It means we are increasing the velocity of the bike. Practically, we say it as the speed. But what is that exactly in the terms of physics? It is velocity. Why? Because bike is moving in a certain direction. Okay, let's ignore that fact and let's come to acceleration. So when we are increasing the velocity of bike, and after each second, suppose after 1 second the bike's velocity is 3 meter per second. After 2 seconds it is 4 meter per second. After 3 seconds it is 5 meter per second. So you can conveniently calculate that in each of the 1 second the bike's velocity is increasing 1 meter per second. 1 meter per second. So my dear, this is the acceleration of the bike 1 meter per second. If at time t0 the velocity is equal to 3 meter per second, and at time t1 the velocity is equal to 5 meter per second. Okay, so acceleration is equal to t1 minus t0. Okay, basically v2 minus v1. Okay, so here 2 meter per second is equal to 2 meter per second. Okay, got it? So this is something which we need to understand. Okay, everyone. So this is the acceleration, meter per second square. Meter per second square is the unit of acceleration. What is the unit of acceleration? Meter per second square is the unit of acceleration. Okay. Clear, everybody? I hope it is clear to all of you. Meter per second square, right? It's very, very simple to understand the acceleration. So acceleration is the increase in the velocity of any moving object per unit time. Per unit time. All right? Remember that. However, if the body is moving at a constant speed or say constant velocity, then it is called as, right, it is called as the constant speed. However, it may be at the accelerated motion. Accelerated motion means what? Means suppose previous second, right, at the previous second the body was moving at 30 meters per second, but at this after 1 second it is 31 meter per second. Okay, so this is the accelerated motion. This is the accelerated motion. Now what kind of questions do we expect from this kind of topic, acceleration and velocity, etc.? So guys, it's very, very simple. The kind of question we expect, that is here, that which of the following is true. Okay, acceleration is measured in meter per second square. Second, acceleration is a vector quantity. Okay, third, acceleration is measured by odometer, right? And fourth, both 1 and 2 are correct. Okay, everyone. So such kind of questions are asked. You can see this particular paper, right? So guys, you must have heard of the terms like odometer, speedometer, etc., etc. Let me just sit here. Okay, odometer, speedometer, etc. So such kind of questions can also be asked in the examination, where they give you the name of some instrument or some device, and then they ask you about particularly about its application. Okay, clear everybody? So acceleration is measured in meter per second square. That is absolutely correct. It is a vector quantity. Absolutely correct. Acceleration is measured by odometer. Odometer is basically something which measures the distance traveled by vehicle. Okay. So the vehicle covers a certain distance that is actually measured by odometer. For the acceleration, we have the accelerometer. Or for the velocity or the speed, we have the speedometer, right, everybody? So that is how it happens. Accelerometer, yes. Odometer is something which measures the distance. You might have seen that that every bike or every car, it has got a very interesting white piece in the center, which keeps on counting every meter that it covers. Okay, so that is there in the bikes or in the cars, which tells you that how many kilometers in total has your car covered. Okay, how many kilometers has your car totally traveled. Okay, that is odometer. Okay, so this is the question that you can expect now. Now guys, talking about the next physical quantity, which is a very important aspect in the classical mechanics, that is the force. Guys, when we connect sorry, when we connect the force, what is exactly the force? Force is something which is a kind of push or pull action, and it actually creates some sort of displacement, some sort of change in the position of an object. So unless you do any kind of change of the position in the say that any particular object is there, and you cannot change the position of that object, it doesn't actually lead to any kind of force, right? Now let me tell you that force is always a vector quantity, which means that you have to provide a certain direction. In the force. Either the force could be eastwards or the westwards or the downwards or the upwards. Any particular direction could be there in which the force is applied. And what is that force, by the way? Force is either the pulling effect, or force is either the pushing effect. Okay, that kind of effects that we are talking about. So what is exactly the force? So guys, when we say that there is any object with definitely a certain mass, and we are trying to change the position. We are trying to change the position of that particular mass. Okay. If it is stationary, we are trying to move it. If it is moving, we are trying to stop it. Okay. So guys, we will have to apply something. That something is called as force. Okay. That something is called as force. Remember that. Force and pressure both are the same. Actually, when we talk about pressure, pressure is basically that when the force acts upon a certain unit area. So pressure is force upon area. Force upon area. Okay, remember that. Pressure is force upon area. They are both not the same. But it is an interesting question. So guys, now when we talk about that, suppose there is any object. Now, there is any object and the forces of various magnitude, they are working in the different directions. Then what will be the outcome ultimately? Let me ask you this particular question. Suppose if there is this particular object and we have say 10 Newton, we have 20 Newton, here we have 30 Newton, and here we have 10 Newton. So guys, what will be the result of the ultimate application of this force? The ultimate balance or ultimate position of this particular object, suppose O. Where would this O move, or in which direction? So question is, in which direction will the object O move? In which direction will it move? Yes. And let me tell you that this is north, this is south, this is east, and this is west. You have this particular this particular compass. So in which direction it will move? Towards the east, towards the west, towards the north, towards the south. And guys, this kind of questions you can expect in the examination as well. This kind of question you can expect in the examination as well. It will move in the direction east. East. And why? What is the reason? What is the reason, my dear? Because remember, okay, because the opposite forces cancel each other. Okay, cancel each other, and forces in same direction are added up. Okay, it's very, very simple. So when we have the forces acting up in the in the opposite direction, both of them cancel each other. When they are equal in the magnitude, 10 Newton, 10 Newton, the net effect becomes zero. Net effect becomes zero. Okay, everybody. And when we say 20 Newton from the east to the west and 30 Newtons from west to the east, then what will be the net result? The net result after cancelling each other, so 20, 20 will be cancelled, 10 Newton towards the east, that will be still working on this object, and therefore this object will move towards the east by the effect of the force of 10 Newton. This is the kind of question you should be expecting, my dear. This is the kind of question. Very simple, very easy, and also thought-provoking kind of question. Okay, right, everyone? So apart from that, if we talk about the effects of the force here, It can actually bring any kind of moving object to the rest. These are just silly things you can actually understand. The force is basically something that is used to make any kind of object change its position. That's very simple. If it is object is accelerating, the force will bring it to the rest or to the constant velocity. If the force is moving with a constant velocity, the force will try to bring it to the rest. If the if the object is at the rest, the force will try to accelerate it and to move it forward. So anything which is happening, the force tries to change its original condition. Okay. So guys, now when we talk about the people like Aristotle and all that, though their ideas are like no more feasible yet or no more applicable yet, but still they gave some lines like, for example, the uniform motion requires the force, otherwise it is always going to have the deceleration. So in order to make the uniform motion at a constant rate, obviously you need to have some sort of additional surplus or additional input. Okay. Well, Aristotle and Galileo are not that much important. Newton is very much important. Newton actually was a student, as well as later on he became a great scientist, and he wrote a book called as the Philosophus Naturalis Principia Mathematica. Okay. In this particular Naturalis Principia Mathematica or Principia Mathematica, he talked about the laws of motion. Okay. And when we talk about the laws of motion, there are total 3 laws of motion which Newton actually gave, and each of them are very crucial to understand the nature of the movements or nature of the motions. Okay. So here let me tell you, the 3 laws of Newton. 3 laws of Newton. The first law, the law of inertia. Second law, the law of conservation of momentum. Okay. Conservation of momentum. Okay. And that is the law of equal and opposite reaction. Okay, everybody. So these are the 3 basic laws about which we talk in our the laws of Newton. Do we need to understand the derivation of these laws? Absolutely not. But do we need so many examples of these laws? Well, 100% yes. So guys, laws of inertia. Now, what does it mean? Actually, we have several types of inertia. We have the inertia of motion, or inertia of rest, first of all. Inertia of motion. And we have the inertia of direction. Inertia of direction. Got it, everyone? So if we are moving in a certain direction, we will keep moving in that direction even if we are going to change the direction. So we need to understand that what is the meaning of inertia. Guys, inertia, that is the word which comes from or which is derived from the inert. Inert means inactive. Inactive means stationary or stable. Okay. So suppose this particular object is at the moment, it is at the rest. So it will continue to be in the rest unless we provide some sort of force like removing this particular hand. Removing this particular hand, it immediately it brings the gravity into effect, and that gravity actually pulls it downwards, okay. So inertia of the rest, it tells you that any object will remain at the rest. If it was originally at the rest, it will remain at the rest unless an external force is acted upon it to change its position of rest. Which means, suppose if it is kept like this, it will be kept like this forever, unless one external force that comes and pushes it like that. Okay, pushes it like that. Okay, then it is moving. Why? Because an external force is working upon it. If there was no external force, there would be no movement. Got my point? Similarly, my dear, inertia of motion. Okay. So suppose if this is moving, like suppose this is moving. Okay, slowly it is moving, but it is getting stopped because of the external force, that is the friction force, which is stopping it. So guys, suppose any object is moving, so in order to stop that object, we need to apply certain force, otherwise it will not move, or sorry, it will not stop, it will continuously moving, right? So any object tends to keep its position in the same way unless an external force is acted upon it to change its position. That is called as the first law of motion. So guys, how many of you understood the first law of motion? Right? I hope everyone understood this point. Yes or no? Guys, tell me, yaar. Come on. It's very, very easy to understand. So if a bus is moving, it will keep on moving if you don't apply the brakes. If the bus is standing, it will keep on standing if you don't apply the acceleration force on it. If an object is a ball is moving, if a ball is moving, okay, if a ball is moving, it will keep on moving and moving unless there is no effect of the friction or there is no stopping the ball with the hands. Okay, that is the law of inertia or the first law of motion. Okay, everybody. Amritanshu, what did you not understand? Please ask. Please ask Amritanshu. So guys, how many examples of this particular law? How many examples of this particular law? There are so many examples. Any moving object will not stop if there is no external force acting upon it. So Amritanshu Kumar did not understand the first law. It's okay. Amritanshu ji, the first law simply states that any object tends to preserve its original status of motion. If it is moving, it will keep on moving. If it is at the rest, it will keep on being at the rest. And when will this condition change? When there will be an external force applied. Otherwise, no change in the position. That is the first law. Okay, that in order to change the status quo of any object, you need to apply external force. Okay, Amritanshu, is that clear now? Now guys, if we talk about the examples, so the first law have several examples, like for example, say this one: inertia of the rest, inertia of the direction, inertia of the motion, uniform motion. Let us suppose that you are standing in a metro, you are traveling in a metro or traveling in a bus and standing properly. But at the same time, if the metro or bus, it applies a sudden brake, you will be like that. You will be like that. Why? Because your body is moving in the forward direction. It is moving in the forward direction along with the train. Train is stopped. Train is stopped because of the applied brake, but your body doesn't have a brake, so it will be pushed forward because of the inertia of motion. Inertia of motion. Okay. Yes, Sanjay, absolutely. Your body was in the motion and it wanted to continue in the motion itself, but it had to stop because the system is stopped. Similarly, my dear, the inertia of the direction. Inertia of the direction. How many of you have actually felt, right? How many of you have exactly felt that when you just turn a vehicle very quickly, then your body actually forces you outwards towards the window side. Okay. Similarly, if you just turn the car leftwards, then the body is again on the other side. So in the hilly areas, you are sometimes on the window side, sometimes on the aisle side, and that keeps on happening. This is the inertia of direction. Inertia of the rest, it's very simple, that this coin wala example is given here, that if the coin is kept on a paper and you just hit that paper very sharply, the paper just moves out, but the coin, it was at the rest, it wanted to keep that position at the rest, and therefore the inertia of the rest. Inertia of the rest. Okay, that is the these are the three types of inertia that we considered in the three types of movements under the first law of motion. But the second law of motion, guys, that is more about the conservation of the momentum. So total momentum of any object is conserved, and it is transferred. Okay. So my dear, suppose any object, what is momentum first of all? So what is momentum? Momentum is actually the product of your velocity and the mass of that particular object, which is having a certain velocity. So this is simply m into v. Like suppose my mass is say 75 kg, and I am having a velocity of say 2 meters per second. 2 meters per second. So what will be the momentum? The momentum will be 150 kg meter per second. Okay, everyone, that will be the momentum. Now let me tell you, the rate of change of momentum means what? The rate of change of momentum is actually the force, the force which is actually applied in order to bring that momentum to absolutely zero. Got it? A velocity absolutely zero. So here let me tell you that if this is mass and this is velocity, then guys we all understand that this is momentum. Okay, this is momentum, or say P, right? Okay. Got it, everyone? Now when we talk about the rate of change of momentum, basically what does it mean? It means that mass into rate of change of velocity. Okay, rate of change of velocity. Okay, so here let me tell you that mass into acceleration. Got it? Acceleration. So guys, actually, the rate of change of velocity is known as acceleration. This is what we understand. The mass does not change, it remains constant. So what changes? Only the velocity changes. So the velocity changes, that means there is some sort of acceleration happening, and therefore the mass into acceleration, that is the exact value of the force which is required to bring the momentum from exceptionally high value to the zero value. Okay, so guys, if an object is moving and we want to bring that object to the absolutely rest, then my dear, we will have to apply the force is equal to the mass of the object into the acceleration at which the object is actually reducing its velocity. Like for example, suppose a truck of 2000 kg, right, velocity 60 kilometers per hour. Okay, it hit a rock and calculate the force. So guys, what will be the force that will be actually exerted by the rock and the truck upon each other, which would be resulting into the immediate halt of the truck? It will be the mass into acceleration. Acceleration would be how much? So velocity is basically 60 kilometers per hour, which means that it will be 1 kilometers, right, per minute. Okay, or you can further divide it to calculate the per second wala hisab, and that would give you, right, the velocity, and the rate of change of velocity is acceleration exactly. Here the earlier velocity, that is suppose x meter per second, final velocity is 0. Okay, is 0 because the object is at the rest. So here simply you can multiply the mass with the velocity, and the required value of the force you will get by this simple multiplication, because you consider that the truck is completely stopped. Okay, so guys, this is how you can actually calculate, or you can actually understand that this is why, this is why when a bird hits a flying aeroplane, this results into the crash of the plane because of the severe amount of force which is generated because of this collision. So now there would be a question. Which of the following is an example of second law of motion? Okay, number 1, a boatman pushing or rowing his boat through the water. Second, a bowler, right? Sorry, a batter. A batter hits the fast ball for a 6. 3, a bird hit crashing the plane. And fourth, the collapse of window after a hit of stone. Option A, 1, and 2, option B 2 and 3, option C 1, 2, 3, option D 2, 3 and 4. Okay, everyone, answer this particular question. After that we will take a break, obviously, don't worry. Answer this question now. Guys, this is the kind of question they would be asking you from the topic of force, motion, etc. A boatman rowing his boat through the water. A batter hits the fast ball for a 6. A bird hit the crashing, bird hit crashing the plane. The collapse of the window after the hit of the stone. So guys, let me tell you that a boatman or a rower rowing his boat, that is not the second law. That is not the second law. Okay, that is not the second law. Or it is the second law. No, actually it is very simple. It is very simple that you are pushing that behind and it is pushing you up in the front. So that is the third law of motion. The statement 1 is the third law of the motion. A batter hits the fast ball for a 6. Guys, the fast ball is moving very fast, but you are applying the absolutely hard force on that, right? So in order to stop that, moving force, you need to apply a greater force. Okay, so basically the second statement is more of an example of the first law. Okay, more of an example of the first law, but at the same time it also satisfies the second as well as the third law. So my dear, the second statement is a floater statement. It fits into every position, the first law, second law and the third law also. Okay, because the ball hits the bat also feels the impact of it, and at the same time the bat at a greater speed hits the ball, so the ball's direction changes, right? Its velocity changes, which means that it is the first law. But at the same time there is the huge reckoning, the impact upon the bat surface as well as the ball surface, that is the second law. Okay, so first, second and third all applicable in this. The bird hit, the second law. The collapse of window, the second law. Okay, the second law. Got it? So 2, 3 and 4 will be the most suitable answer for this. Okay, that will be the answer. Clear, everybody? How is the bird hit applicable for the second law? Yes, bird hit is applicable for the second law because the plane is moving at a very, very fast speed. Okay, and when the two moving objects, when they actually are moving in the opposite direction, then their speed is actually added up. So the bird is itself moving on a certain speed, and contrary to the plane, the speed effective for the bird hitting the plane, that will be the speed of the bird plus the speed of the plane, and that will be suddenly bringing the bird as well as the plane at a certain halt, Okay, so that is the reason because of which the enormous force is generated because of that bird hit at a very high speed. Okay, Ashirwad, so that enormous force which is generated because of the bird hit on the surface of the plane, that is enough to make that plane collapse. Okay, the collapse of the window after hitting the stone. Window is something stationary like a rock, and the stone is coming at a certain velocity. When the car hits the rock doesn't move and the car gets crashed. Okay, That is the combination of the second as well as the third law. Okay, first law is also there, but second law is obviously there. Why? Because on the car, after getting hit, enormous force is generated. Similarly, on the window, the moving stone generates an enormous force on that surface, which leads to the cracking up of the window. Okay, that is the case. That is the case. Rishabh says, but there will be some movement after the hit. Yes, of course, Rishabh. Of course, my dear. Actually, you know what? There is not a single example where you can say that only the first law is applied, only the second law is applied, only the third law is applied. There are always more than one conditions or more than one laws of motions which are applied almost in every case. Okay, so apart from the first example, in all these three we have the presence of second law of motion as well as the other laws also, but most prominently the second law. Okay, so guys, that is the answer. Now I can right, can I ask some question, because most of the students, I can see that, guys, if you are needing a break, so let me give you a 10 minutes of break, but not more than that. So I think that would be sufficient, right? So let us take 10 minutes of break for that. 10 minutes of break. Exactly, Rishabh, exactly. Third law is also satisfied. Okay, everyone. So let us now move to the next topic that we are going to cover. And we are going to cover the next topic, that is your heat and thermodynamics. Okay, heat and thermodynamics. So we have probably covered significant examples as well as some important practice questions also related to the laws of motion. And now talking about the basic topic of heat and thermodynamics. So first of all, let us understand what is heat. Okay, what is heat, guys? Heat is something that is expressed as a form of energy, as a form of energy. And what kind of energy, by the way? What kind of energy? So exactly the total measure of the kinetic energy that all the molecules of any kind of system or any kind of object they do possess. So in order to understand the heat energy or the kinetic energy, let us understand the energy first of all. Okay, so if we talk about say energy, okay, energy. So guys, energy is actually the capacity to do the work. Okay, however, in order to do the work we need to generate and apply the force. Okay, so we can say that energy is something which helps us to exert or absorb a certain degree of force. Okay, so this energy is basically what? Energy is basically can be of various types. Okay, various types. Okay, so for example, on the basis of position of any object, on the basis of the movement. Okay, movement. So this is called as the potential energy. Potential energy. This is called as the kinetic energy. Okay, then guys, on the basis of composition, that is your chemical energy. Okay, or on the basis of your structure and movements. Mechanical energy. Okay, guys, there could be many more types of the energy. You can just keep on writing and categorizing it. However, there are these of energy types are some of the basic energy types. Like for example, potential energy, kinetic energy, chemical energy, mechanical energy. There are the other types as well, like the electrical energy. There are other types as well, like for example, we have the heat energy. So on the basis of temperature, Okay, on the basis of temperature and movement of particles. Movement of particles. Then we have the heat energy. Right, everybody? Heat energy. Now, we are actually just considering it, yeah, we are just considering it to be the basic types. Basic types. For example, when we talk about the structure and the movement, it is called as the mechanical energy, and mechanical energy is basically your potential and your kinetic energy. Why? Because the structure that provides you a certain position. For example, suppose there is a rubber band, there is this rubber band, and then we have just entangled the rubber band like this. Okay, and this is the structure of this particular system. So this rubber band and this pen and this object, actually this entire setup has a kind of mechanical structure, kind of mechanical constrained motion. So it possesses some sort of potential energy, which is a type of mechanical energy. And as soon as you remove that ribbon, it just hits in a certain direction, and that particular energy which is transferred immediately after removing that ribbon, that is your kinetic energy. So guys, each of them are actually interconnected, which indicates that energy is something which cannot be created, cannot be destroyed, but it could only be transferred from one form to the other form. Okay, that's very simple thing that we are going to cover. Guys, let me tell you that many of you might be having the science background and you might be thinking that these are all distinct things. Yes, if we try to study it separately, if we try to calculate and all, then obviously these are all different. But for the purpose of such examinations where we have very general approach of getting the questions, you have to consider the most interconnected way of understanding the energy. Now let us talk about the heat particularly. So heat is a type of energy, we understood that, and it was the result of the kinetic energy particularly possessed by the molecules of that particular object. Okay, now the heat is actually measured in the kilocalories or in the joule. Usually the most common unit is calorie or kilocalorie, but the SI unit is actually joule. However, now what is exactly this particular calorie or joule? So guys, when you have that unit mass of water and the amount of heat that is required to raise its temperature by 1 degree Celsius, actually by 1 Kelvin and 1 degree Celsius, both of them are same, then we call it as a heat of 1 joule. Okay. However, when we talk about right, sorry, heat of 1 calorie. However, when we talk about 1 calorie, you can actually count 1 calorie as 4.18 joules. So guys, 1 unit gram of water, the temperature is raised by 1 degree Celsius or 1 Kelvin, it becomes 1 calorie of heat. And similarly, if you divide that 1 calorie of heat by 4.18, you get 1 particular joule. Okay, so joule and calorie are interrelated. Joule and calorie are interrelated. Now, the role of temperature, what that comes into the heat. So what is temperature and how is that related to heat, or how is heat related to temperature? Because temperature is a fundamental quantity. So temperature is a fundamental quantity which tells you the degree of heat. That means, dear, heat is actually, always a relative thing. Heat is always a relative extent of energy or relative level of energy. For example, suppose if my temperature is already 50 degrees Celsius and I am touching something at 30 degrees Celsius, it will not be something which will make me feel heated, right? Rather, it will be making me feel cold, right? So basically, heat is something which is very much relative and dependent upon the degree of temperature. So guys, exactly what is temperature? So total quantity of the heat in any substance or the article which is measured or measurable by a certain degree, it is called temperature. Okay, so the hotness or the coldness that is measured with the help of a fundamental quantity, that is called as temperature. Okay, everyone. So therefore, let me tell you that heat is actually something that cannot be stored or that cannot be kept at a constant value. It is always a relative thing. So there are always two things, two you can say elements in any kind of heat circuit. Any kind of heat circuit has two different elements. The one is called as the source, the other one is called as the sink. Okay, the source is at the higher temperature, the sink is at the lower temperature, and the heat is something which moves from the higher temperature to the lower temperature, or from the source to the sink. Okay, everyone. So here we need to understand the basic properties that suppose this body, it is at the temperature T1. Okay, and there is another body which is at temperature T2, where T1 is greater than T2 and where T is equal to temperature. Okay, so this particular temperature is the result of, or it is basically the degree of heat. Okay, okay, everyone. So T1 is what? T1 is the degree of the heat. Heat is basically here Q. Okay, and this is Q1. This is Q2. So Q1 is moving towards Q2 due to the temperature difference. Okay, and here let me tell you that here the heat is transferred. Heat is always transferred from a higher temperature usually called source to a lower temperature usually called sink, called as sink. So a higher temperature system actually receives more heat and actually possesses more heat, and it sends the heat towards the lower temperature system, and that actually results into the transfer of the heat. Now the question arises as Adarsh Dubey ji rightly points out, that they need to be in contact for the transfer. Is it so? So can we say that the heat transfer is always required of any kind of contacts, or how many types could be there, how many methods could be there for the transfer of the heat? Yes, those students who are saying that the heat transfer always requires the medium or always requires the contact, guys, how can we receive the heat from the sun? Are we in the contact with the sun? Absolutely not. So my dear, the heat transfer could be The heat transfer could be of three types or by three types. Could be by three types. Okay, everyone. Number one would be conduction. Number two would be convection. And number three would be radiation. Okay, conduction, convection, and radiation. Is that clear, everybody? We will understand the meaning of each of these three terms, but for now, have you understood the setup of the, basically two bodies which are having the varying temperatures? One particular temperature is at the higher level, other temperature is at the lower level. The temperatures indicate the degree of the heat, degree of the hotness or the coldness present in both the systems. And here, the temperature which is higher, that particular system is known as the source, and the temperature which has the lower value, that system is called as the sink. And the heat Q1 is basically, it basically transferred to the sink in the form of Q2, and Q1 is higher than Q2, obviously. So this is actually called as the source to sink heat transfer. Okay, source to sink heat transfer. So guys, this particular movement of the heat or transfer of the heat, it is a kind of process called as thermodynamics. Okay, everybody. So let me tell you that the understanding the process of movement of the heat, that is your transfer from hotter to colder body, is called thermodynamics. Okay, everybody. So basic thermodynamics, very, very basic thermodynamics, including the laws of thermodynamics, the 0th law, the first law, the second law, the third law. All these laws of thermodynamics are very crucial to understand the basic one-liner, two-liner questions, or say one choice, multiple choice questions in the examination that is asked. Okay, so here, if we talk about measuring the temperature first, so guys, there are various kinds of the scales that we actually have. The scales include the various kind of scales, like the Rankine scale is there, Reaumur scale is there, Kelvin scale, Fahrenheit, Celsius, and all that. Usually we have the very popular scales of the temperature measurement, which include the Celsius and Fahrenheit. These are two very common, usually I think in the measurement of fever and all that. Okay, but we have the standard or SI unit of temperature measurement, which is called as the Kelvin. Okay, this is the last slide. You can actually take a look on that, Prathamesh. Okay. Clear, everybody? So I think this is understood by all of you. Now let us understand the different scales of temperature, right? Different scales of temperature measurement. And guys, there are different scales of temperature measurement, which mainly include which ones? Which mainly include the Celsius, Fahrenheit, Kelvin, and Reaumur. Okay, when we talk about the Celsius, it is usually the boiling point and the freezing point of the water and they are divided into the 100, you can say sections or 100 points. Okay, so here 0 to 100 degrees, that is the scale which is used, and almost all the relative temperatures are measured in this particular scale. Okay, so when we divide the temperature of the freezing point and the boiling point of the water into 100 points or 100 parts each of the equal value, we get the Celsius. We get the Celsius scale. Then, guys, we have the Fahrenheit. We get the Fahrenheit. So Fahrenheit is something, that is expressed with the help of very old system of temperature measurement, where we have 32 to 212. 32 to 212. If you understand one thing, guys, actually, this is something which adds up, you can see, and calculated with the reference of Celsius. So how can you exactly calculate it with the help of, you can say, Celsius, right? So total 180 segments are divided, or equal units are divided here. So 32 to 212 total difference, that is 180. So you divide it into the 180 gradients, and then you measure the temperature. Celsius scale is 100 gradients, and Fahrenheit scale is in 180 gradient. If you want to convert Celsius into Fahrenheit and vice versa, what should be the formula here? So it's very simple. This is the formula. Okay, that is C upon 100 is equal to F minus 32 upon 180 upon 180. That is the simple formula that you have to apply. And guys, sometimes they give you the questions of conversion. Sometimes they ask simply the scale, the name of that scale, or the invention year of that scale. Such kind of questions are also possible to be asked. Okay, so just be prepared for with this basic information. There is nothing more that is required. If you want to convert the degree Celsius into the Reaumur scale, then what would you do? Simple, right? It's very simple. Celsius upon 100 is equal to R by 80. Just calculate values, as simple as that. Okay. So guys, let me tell you that there is only one point in the Celsius and Fahrenheit scale both where you have that value same in both the scales, and that is minus 40 degrees Celsius and minus 40 Fahrenheit. Actually, can you say that? Let us understand. So 40 minus 0 by 100, is equal to minus 40 minus 32 divided by 180. So 40 by 100 is equal to 72 by 180. Okay. 8 by 20 and 8 by 20. So both of them are 8 by 20. Got it? So both of them, they come to be absolutely equal. So this is proven. This is proven that the temperature of minus 40 is same in Celsius and Fahrenheit. In Fahrenheit. Okay, everyone? Did you all understand that? How can I say that? How can I say that minus 40 temperature in the Celsius and Fahrenheit are both exactly the same? It is because of this calculation. This is the formula of Celsius compared to the Fahrenheit scale, and in Fahrenheit scale just replace F with minus 40, and replace C with minus 40. Okay, and you would observe that this becomes 40 by 100 and actually minus 40 by 100, right? And this becomes minus 72 by 180. So overall it comes minus 8 by 20. Both of them are reduced to become 8 by 20, which means both of them are equal. The fractions for both of them are equal. Okay, so only on that particular point we have the equal temperature values for both the scales. Otherwise, if you talk about other values, for example, the human body temperature on the Fahrenheit scale is 98.4 degree Fahrenheit. And when we talk about the degree Celsius, we have how much? We have 37 degrees Celsius as the human body temperature. Do you understand? I hope everyone understood this point, right? Now, guys, we talk about a very important point related to the heat and thermodynamics, of course. That is the change of phase and change of, or simply the change of phase and the types of heat which we consider, right? Rishabh did not understand. Rishabh, do you know the basic calculations, my dear? Do you know the basic calculation? Look at this one. There is a basic formula. There is this basic formula. Celsius by 100 is equal to F minus 32 divided by 180. Do you understand this formula, Rishabh? This is the formula with the help of which we can equate any kind of temperature in Celsius as well as in the Fahrenheit. Suppose if we have like human body temperature, if we have suppose 98 Fahrenheit. So what will be the value in Celsius? C by 100 is equal to 98 human temperature, human body, approx. Minus 32 divided by 180. So here it is equal, that is equal to 5, 4 and 0, 0 divided by 180. C is equal to this much. Okay, 0, 0, 2, 50, right? Okay, that is your a second. 6, my dear, 6, 70, right? 73 something, right? So it is going to be equal, right? Just a second, everybody. Just a second. 62 divided by 180. Okay. So 62 divided by 180, right? 62 divided by 18, right? So that is basically here, right? 6200 divided by 180, 0, 0, then 9, 3, 1, 0, 3, 1, 0 by 9, then 330. No, 30, no, 30, no, 30, 33, right? 33, 34, right? Approximately 33, 34 degrees Celsius, that kind of value is coming. So 33, 34 kind of value is coming. So here we are having the approximate value, right? Approximate value, right? But overall, this calculation is saying that, what is this calculation saying? It is saying that at the temperature minus 40, both the scales show us the same value. Let us find out. So minus 40 upon 100, this is the Celsius value, and minus 40 minus 32 upon 180. So the argument is saying that both of them are same. both of them are same if we put the C is equal to F is equal to minus 40. If C is equal to F is equal to minus 40, then the scale becomes same. Okay, so here you can see that minus 40 by 100, and here it is minus 72 by 180. So 9, 20 and 9, 8. So that is equal to minus 8 by 20. And this, here it is 5, 20 and 8. So minus 8 by 20. So for the value of C is equal to F is equal to minus 40, both of them are satisfied and both of them come to the same value. So that is the indication which proves that at minus 40 temperature, both the scales are equal. Which both scales, Fahrenheit and Celsius, are both equal. Okay. However, for any other temperature, you can see that if you suppose put the equal values in both, like C, right? Let us put the 32 degrees Celsius here and 32 Fahrenheit here. So it will become 32 degrees Celsius, which will be, right, 0, right, right. So this is why it tells you that 0 Fahrenheit is equal to 32 degrees Celsius. Okay, 32 degrees Celsius, remember. Anyways, so here we were talking about the water, right? Particularly water, and from the example of water, we wanted to understand the various concepts of the heating process, and that includes the freezing, melting, condensation, evaporation, such kind of thing, and also the effective heat, latent heat, etc., etc. Okay, everyone. So let us understand these various terminologies with the help of the water as an example. Okay, everyone. So here, when we talk about the various phases of the matter and conversion due to heating, okay. So guys, here suppose the water we are taking up. So first of all, it is ice. Okay, ice is heated up, and this plus delta H, and that actually leads to the melting is equal to water. Okay, water is heated up plus delta H, that leads to the, right, boiling, and it becomes steam. But the steam is then, right, steam is then cooled, or say condensed, that is minus delta H, and it becomes water. Okay, the water is further cooled, right, further cooled, and that is your that is freezed, and that becomes minus delta H, that becomes ice. Okay, so basically this is the water through its different phases. The water actually receives more and more heat and gains the energy levels and it becomes steam, the gaseous stage. But after the gaseous stage, if you keep on heating it further, it remains in the gaseous state only and keeps on spreading up, right? However, if you reduce the heat of that system and the temperature is reduced, the heat is lost, losing the heat of the steam leads to the condensation process, and the water is again from the gaseous state into the liquid state. Okay, after that the water is further cooled, and this leads to the freezing and loss of the heat, and the water is from the liquid state to the solid state. So this is liquid, this is solid, this is liquid, this is gas. Okay, so my question to all of you is that it is very well understood that the water is actually changing its phases due to the adding up or reducing the amount of heat by increasing or decreasing the temperature. But what is exactly that particular heat which is called, right? What is that particular heat which causes the change of the phase at the constant temperature? Right now, so here what happens? Here what happens that the phase changes from solid to liquid and liquid to gas. Okay, so solid to liquid at constant temperature, and liquid to gas at constant temperature, Let us suppose that this constant temperature is T1 and this constant temperature is T2. So my dear, if we say that T1 is constant, that means while the water is in the solid state and it is changing into the liquid state, the state is changed, the phase of the matter is changed, but the temperature is same despite absorbing the heat. So where is that heat gone, and what is the name of that heat? So guys, that heat is actually called as the latent heat. Okay everyone, that heat is called as the latent heat. Okay, latent heat. So you can see that the solid, liquid and vapor, so this particular the constant temperature changes the phase despite due to a hidden heat called latent heat. Okay, latent heat. It could be the latent heat of fusion and the latent heat of vaporization. Latent heat of vaporization. Okay, so there is a certain type of heat which is not measurable by the thermometer because it is not used to increase the temperature, but it is used to change the phase of the matter. Did you get this last point, everyone? There is certain value of heat which is hidden, which is not measurable by the thermometers. The temperature of that is not measurable by the thermometer. Why? because that amount of heat is utilized to change the phase of the matter instead of changing the temperature. That is called as the latent heat. Latent heat, if it is added up, it becomes latent heat of fusion, which changes the status or the phase of the matter from solid to liquid, or the latent heat of vaporization from liquid to gas. However, if the same latent heat is removed from the system, then it becomes the loss of the latent heat, or the simply the latent heat of condensation, which changes the gaseous steam into the water, okay, which changes the water vapors into the water, and the latent heat of freezing, basically changing the water into the solid ice. Okay, so this is very important, guys, and for that you also need to understand that there is something called as the specific heat as well. This specific heat is actually when we have that 1 kilogram, 1 kilogram of the water, and we need to increase the temperature of the water by 1 degree Celsius, the amount of the heat that we need. Okay, that is the specific heat. Okay, that is the specific heat. Usually it is expressed in kilogram. However, in the definition, they can also give it in the grams, but the value of the specific heat is then slashed. Okay. Anyways, so let us talk about the types of the heat transmission as we discussed already. अच्छा, latent heat एक बार फिर से समझा दो ऋषभ जी. latent heat का मतलब आप एग्जांपल से समझ लीजिए. Just understand it with the help of example here. Suppose this is 0 degree and it is ice, but 0 degree water, okay, 100 degree boiling water, but 100 degree steam. So guys, we know one thing very clearly, that the heat, the degree of the heat is measured with the help of temperature. But here we cannot see, Rishabh, that temperature is rising. Can we see that? Is there any difference in the temperature T1 and T2? Is there any difference? Absolutely not. So latent heat does not change the degree of hotness. It only changes the phase. Okay, so this is called as the latent heat. So that particular heat which does not change the value of temperature, but only changes the phase of the matter, that is called as the latent heat. Rishabh, is that clear? So that particular heat which changes the ice to water at 0 degree constant temperature, this is called as the latent heat of fusion. Latent heat of fusion. Okay, delta H fusion. This is called as delta H, okay, vaporization. Okay, delta H vaporization. Clear? So guys, there are different types of the heat transfer. We have the distinct types called as the conduction, we have the convection, we have the radiation. All these are the different types that we need to understand. What is conduction? So conduction is basically the transfer of the heat by the direct contact between the source and the sink, between the body 1 and the body 2. Okay, Rishabh says that fusion, there is no change in state. Wow, 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 bahut achhe, very nice. Rishabh ji, fusion, there is no change of state. I'm talking about the fusion that is melting, not the nuclear fusion, my dear. Fusion is also having a meaning called melting. So you can say that it is the latent heat of melting. Okay. So fusion means there is the change of a state. It's not nuclear fusion we are talking about. Okay, Rishabh? So don't get confused between these two different terms. I hope you got the point. So guys, we are talking about the conduction, right? Conduction. So here, simply conduction is something, where the heat is transferred from the one body to the another body, right? From the another body, there is the direct contact of the two bodies, and the heat is transferred with the help of those contacted molecules. Is that clear? The heat is transferred with the help of those contacted molecules, like this. It is contacted. So these molecules which are heated up here, they transfer the heat to the very closely packed molecules, and they keep on heating the one another, and then they transfer the heat to that one molecule in this particular object, and then the other molecules are subsequently heated up, and then you have the last end of this one object also heated up. Okay, so here the particles the particles, they simply vibrate. They simply vibrate due to the heat. They do not leave their position. They do not leave their position. Like for example, if you heat this particular rod, suppose it is a metal rod, you heat it here, the other end of the rod will also get hot. Okay, also get hot. Why? Because the molecules are in the close contact, and if you heat it on the one end, it starts getting vibrated. It starts getting vibrating, and once it starts vibrating, then the energy is subsequently transferred from the one molecule layer to the other molecule, and then it reaches to the last state, to the last phase. Okay, so the last state, the last level of molecule is also vibrating because of that heat, and if you touch it, you will also feel the heat. Okay, so that is your conduction. That is your conduction. What is convection, by the way? Guys, convection is something where the molecules move themselves. The molecules, they don't just vibrate, they actually change their position. They actually move from one position, carrying the heat along with them, and they go to the other position and release the heat from that one position to the other position. Example, if we are boiling the water, or if we are moving the steam or pressurizing the steam, then we are transferring the heat by transferring the molecules itself which are carrying the heat. Are you understanding my point? So guys, conduction is usually applicable to solids. Since the molecules are closely packed. Convection, on the other hand, is usually applicable in the fluids, since the molecules are loosely packed and can move upon receiving heat. Okay, so guys, did you both understand both of these, conduction and convection? So convection is always there in the liquid or in the gases. Suppose if you heat that liquid, suppose water, so what happens, that the warmer water near the bottom of the vessel, it actually gets heated up, and it moves upwards and hence ends up heating the water that is upward. Okay, so the liquids exhibit convection. Liquids exhibit convection. Now, what is radiation, by the way? So, guys, when we have the transfer of heat without any medium, okay, transfer of heat without any medium, that is known as radiation. So what are the examples of conduction, convection and radiation? So guys, when we touch the handle of any hot vessel kept on the pressure, kept on the gas stove or anywhere, and the handle is really hot, that is the example of conduction. And what is the convection's example? So boiling the water is the example of convection. Boiling the water is example of convection. And what is the example of radiation? So basically the insolation, that is the heat which we get from the sun, that has the radiation effect. That has the radiation effect. Okay, as simple as that. Got it, everybody? So here we have all these written things and all that, but we don't need to even remember. Okay, everybody. So here the values of the specific heat of melting and Stephen's law, these are not required for you. These are not required. Not required. You can just ignore this. Okay. Now, guys, there are two laws of the cooling and emission and the radiation, etc. So Newton's law of cooling is there. What does it say, by the way? Newton's law of cooling actually says that the rate of the loss of the heat of any body by the process of thermal radiation is proportional to the difference between the mean temperature and the surroundings. So guys, you know what? The mean temperature and the surrounding temperature, if they are both highly different from each other, then the temperature loss or the loss of the heat, that will be fast. More the difference, faster the loss of the heat. So this particular law of cooling is applicable in the cooling up of the tea, the cup of tea, the cooling up of the milk, okay, or drying up of the cloths, all these things. Okay, all these things. So basically, when you see that the tea or the hot cup of milk, hot cup of tea, etc., these things get cold very easily in the colder weathers, in the winters, isn't it? But these things remain hotter for a long time in the summer season, because of the fact that the summer season, we have the difference between the surrounding temperature and the temperature of that cup of tea. The difference is relatively less compared to the difference when it is considered that cup of tea and the winter surroundings. So winter surroundings, the temperature is around 15 degrees Celsius or 10 degrees Celsius, whereas the cup of tea is at 60 or 70 degrees Celsius. Okay, so it is like almost a 50-degree difference. Whereas in the summers, the surrounding temperature is 40 degree, the tea temperature is 60 degree, just 20 degree of difference. So the loss of the heat from the tea to the surroundings, that is less compared to the winters where it is very high, because of the difference of temperature between surrounding and the system. Okay. Then guys, the Kirchhoff's law of radiation. The Kirchhoff's law of radiation, that is very, very important. It states that for a body in thermal equilibrium, the ratio of its emissive power to its absorptive power is equal to the emissive power of black body. Okay, everybody. So basically it says that suppose the temperature and the wavelength of any kind of energy wave, that is same for the black body. So any body, any random body and a black body. What is the black body? The black body is basically which absorbs each and every kind of radiation. That is a black body. Perfect absorption. It says that the ratio of the emissive power to the absorptive power, that will be equal to the emissive power of the black body at the same temperature and wavelength. Okay. So guys, according to the Kirchhoff's law of radiation, no matter what, if it is a black body or if it is a regular body, if you are considering the same temperature and the same wavelength, okay, the proportion of emission to absorption for that one specific wavelength at a specific temperature, that will remain same, either for a black body or for a normal body, which means that any kind of regular body is as good an absorptor as good a emitter, right? So emission and absorption are both proportionate to the wavelength and the temperature at which we are considering that body. Okay, let me show you a simple example of this, then it will be clear. Just a second. Okay, so guys, have a look at this particular page. Proportion of the emissive and absorbing powers of any material object is constant at every wavelength in the thermal equilibrium. Okay, which means that if the object has attained the thermal equilibrium, means the temperature difference between the system and surroundings, that is constant. Okay, and on that condition, what happens? The emissive power and the absorbing power, that is basically constant. No, that is actually constant. Okay, so there is absolutely no difference. There is no difference in the emissive power and the absorbing power when we have the thermal equilibrium for any object, which means basically it is absorbing same amount of heat. It is absorbing same amount of heat as much as it is emitting. That is the Kirchhoff's law. Now guys, what happened here? The two metal balls take some time to attain the container temperature. After that, the enclosure and the two metallic spheres are in the state of thermal equilibrium at the constant temperature, right everyone? So it means that here it is saying that if the wavelength of the light or wavelength of the energy is same and the two different balls are there with the different temperatures, so once the temperature becomes constant, they will remain in the thermal equilibrium permanently. Why? Because they are basically emitting the similar energy as they are receiving. So there is no net change of energy or the heat. Hence there is no net change of the value of temperature, and hence there is constant temperature that we are having here. Okay, so this is basically saying that after attaining the thermal equilibrium, the absorptivity and emittivity both becomes equal. That is your law of Kirchhoff for the radiation, right? We have very less chances that they would be asking any kind of questions from this topic. However, nobody knows that they may ask at least the name of that. the name of that. Okay, so guys, it is possible that they may ask that the Kirchhoff's law is related to, right, electrical. There is also one Kirchhoff's law in the electrical circuits right now, but there is also a Kirchhoff's law related to the radiation, right? So this is also important to understand. Okay, everybody, now try to solve these questions here, right? Okay, so guys, here we are having the thermodynamic processes. These are just simple, I would say, for the reading purpose. Don't try to go into the equations or the details and all. Isobaric bar indicates the pressure. So when the pressure is constant in the heat transfer process, it is called isobaric process. Isochoric, so when the volume is remaining constant in the heat transfer thermodynamic process, then it is called isochoric process. You can expect some simple questions based upon the definitions of these terms. Adiabatic or adiabatic process is where there is no heat transferred, which means in a perfectly insulated system. In a perfectly insulated system. So when we consider a perfectly insulated system involving no heat transfer, that means it is the adiabatic process. And when we say there is the constant temperature in the thermodynamic process, it is called the isothermal process. So there are total how many? 4 types of the thermodynamic processes which involve the certain degree of heat transfer. Okay, that is what we are considering here. Okay, everyone. Now let us talk about the laws of thermodynamics. Guys, again, if you are expecting that we are going to see some detailed derivations, etc., of these laws, absolutely not. We are just going to have some idea that what is the zeroth law, the first law, the second and third law. The zeroth law says that if A is in equilibrium with the B and the B is in equilibrium with the C, then the A is also in equilibrium with the C. Okay, everyone? Right, everybody? So that is what we are going to see in the zeroth law. Got it? And zeroth law is usually applicable in the condition that if one system is in the equilibrium with the second system is in equilibrium with the third system, then the first and third are also in the equilibrium. That is the zeroth law. Okay, they will also attain the equilibrium. Then guys, what is the first law? Energy cannot be created, right? Cannot be destroyed. It can only change its forms from one to the other form. That is the first law. Okay, that is the first law. Zeroth law, I think you understood the zeroth law right now. A, B, okay, C. Okay, so suppose if A is in the equilibrium with B and B is in the equilibrium with C, then if A and C are connected while AB and BC are already connected, allowing heat transfer, then this A, B, C, they all will attain thermal equilibrium. Okay, they all will attain thermal equilibrium. That is the zeroth law. That is the zeroth law. Okay, first law talks about the transfer of the different forms of energy from one into the other form. That is the first law. Okay. Second law says that any kind of entropy in the isolated system that always increases. What does that mean? It means that if you increase the heat of the system by increasing the temperature, the randomness, the degree of the randomness of the system's molecules, that will be increasing. That is called entropy. So basically, guys, entropy is the second law, form of energy is the first law, thermal equilibrium is the zeroth law, and the entropy reaches to or tends to reach to the zero. That is the third law. That means if you reduce the temperature to the absolute zero, the entropy of the system will also follow the trend, and it will also reduce to the almost zero, which means that if you keep on reducing the temperature, the total entropy will also become almost zero. Okay. So enthalpy and entropy are proportional. When we reduce one, the other also reduces. That is the third law. Guys, these four laws are actually the basic laws of thermodynamics. Mahek is asking entropy. Entropy means, Mahek, the degree of randomness. What is the degree of randomness? Suppose this is a room. This room has certain molecules. We all understand that the molecules, when they receive the heat, when they receive the energy, their randomness increases. Okay. So the second law says that the degree of randomness, which is called entropy, obviously your answer, the degree of randomness, which is called entropy, that increases always when the system is isolated. Which means when the system is not transferring its heat to something else, the entropy will remain at a very high value, and it will keep on increasing, because the continuous transfer of the heat from one to the another, that will keep on increasing the friction, right? Anyways, so guys, such kind of things are also there, but these detailed parts are not required in this particular topic. Just solve these questions, and here you can write. For the reference purpose, I have added up some extra information which is probably not needed much, but the thermodynamics zeroth law, the first law, second law, and the third law, these are all explained as well in the detail. But in case if you want to read, you can read it from there. Okay. Do not worry about detailed descriptions and other things. If you are able to answer such kind of questions, you are able to crack the exam. You are able to solve the science questions as well. So which of the following statements are true regarding heat? Heat is a form of energy. Okay. Heat can be reflected by the mirror. Heat is an electromagnetic radiation. Heat cannot pass through the vacuum. Okay. True regarding the heat. Okay, everyone? Yes? Very nice. Ashirwad, very nice. Eliminate 4 and rest, correct. Heat cannot pass through the vacuum. My dear, if the heat is an electromagnetic radiation, which is absolutely correct, because the heat is also possible to be transferred by the radiation. Do you remember that? We studied that, no, that heat is actually possible to be transferred by the radiation. So this is wrong. Okay, this is wrong. Then what is correct? This is correct. Next question. A man inside the artificial satellite feels weightlessness because the force of attraction due to the earth is? Yes. What is the answer to this question, everyone? in the artificial satellite or in the space stations and all that, the force of attraction due to the earth is actually simple air. Come on, force of attraction becomes almost like equal to zero. Force of attraction becomes equal to zero. There is no such role of specifically moon or specifically centripetal force or something like that. Nothing else, nothing else simple as that, because the gravity is right, zero gravity, zero gravity zone, because the earth's gravity is balanced by the gravity of the other celestial bodies. Okay, the gravity of the earth is balanced by the other celestial bodies. That is why the effective gravity is zero. When the ship floats on the water, it displaces no water. The mass of the water displaced is equal to the mass of the ship. The mass of the water displaced is lesser than the mass of the ship. The mass of water displaced is greater than the mass of the ship. Yes, this is very easy. Yes, everyone. How many of you say option number B or option number D? Any other options? Guys, let me show you an example of this one as well. Right. Okay, everyone. So here you can see this particular example. Let me just show you that example as well. Right. So guys, here, okay, look at this one. Okay, it's very simple. You can add it, right? You can add it as well. Look at this picture. Look at this picture. It's pretty simple picture that anything that floats just on the surface of the water is something where when it moves and displaces certain water, that mass of the water that is equal to the mass of the ship, then it floats on the surface. Okay, floats on the surface. Simple as that. Bachpan mein padha tha, all of you, I think. Okay, so that is the mass of water displaced equal to the mass of the ship. Then consider the following statements. The gravitational force exerted by the sun on the moon is greater. Okay. Then what is this, man? The heavy body falls at a faster rate than a light body in the vacuum. Anyone about this? Gravitational force exerted by the sun on the moon is greater than the gravitational force exerted by the earth on the moon. The first is incorrect. The first is incorrect. Heavy body falls at a faster rate than a light body in the vacuum. Why? Why? D is the answer. D is the answer. D is the answer. Heavy body and light body in the vacuum, they will both fall. Come on, yaar. Galileo. Okay, Galileo. Experiment of Galileo. Okay. So light body and heavy body both will fall at the same rate in the vacuum. And why? Why? because if they don't feel any kind of obstruction, okay, they will have the same fall rate. Got it? So no air resistance, nothing, simple as that. Vacuum. D is the right answer. Okay, everyone. So thank you so much, and see you all tomorrow at again same time. Vacuum means when there is absolutely no air. Okay, there is no air. That is vacuum. Okay, guys, take care, and I hope that you solved good enough number of questions in today's class as well. Tomorrow we will be doing some topics which are significant for physics. That will be it. Don't try to go into the deep and the depth of matter as well as the detailing, etc. It's not required at all. Just focus on solving questions. That will be much more helpful than anything else. Okay, take care. Thank you so much. Have a good day. See you tomorrow. Bye-bye.